Hello, today I'm going to be creating a broadcast storm in Cisco's packet tracer so we can see what happens when spanning tree protocol is disabled and layer 2 loops are formed in the network. So here I put down 3 switches, and you can just hold control so you don't have to reselect the device each time. Then here is our 3 user PCs. I just connect them using the lightning cable, which is automatic. We're going to set the IPs, so PC0 can be 192.168.1.3. It automatically recognizes this is a Class C address, so it sets the subnet mask to 255.255.255.0. PC1 will do the same thing. We'll just use .1 at the end, and then .2 for PC2. You can see the link lights are enabled, so orange is still in the listening and then learning states of spanning tree, and then when the devices are fully connected, the link lights turn green as they just did. It takes about 30 seconds, 15 seconds for each of those stages, and now all interfaces are forwarding except this orange one in between switch 0 and switch 2. This is STP blocking this interface on switch 0 so that traffic doesn't form loops in broadcast storms, but we'll disable that right now to watch the fun. So let's go to switch 0, type enable to enter privileged exec mode, hashtag mode, and then conf t, which is short for configure terminal. Then we'll type no span and tab. What we're going for is spanning tree. So what aspect of spanning tree are we configuring? We are configuring VLAN 1. VLAN 1 is the default VLAN, so without configuration, all the interfaces connecting to the switches are operating in VLAN 1. Now the trick is we're not telling the switch to run spanning tree on VLAN 1 because of the word no at the beginning, which is what we want for this lab, to endlessly run ARP and ICMP messages to crash the network. So no spanning tree VLAN 1 on all 3 switches. So I'm going to pull up simulation mode to kind of pause the network, and then we can let these pings fly at the same time. So here on PC1, we will do a continuous ping, so TAC-T followed by PC2's IP address. So in simulation mode, it will not send until we hit the play button. And then on PC2, we'll do a continuous ping to PC3, and on PC3, we'll do a continuous ping to PC1. And now we have loaded up our continuous ping storm, and let's let it rip. Now initially when I hit play, all these ARP messages start flying around. This is pings trying to match MAC addresses to the IP addresses because these hosts have never talked before. When these messages hit the switches flood the frames. They send it out all interfaces besides the one it was received on. Now that happens again because each switch receives those ARP messages, floods them again in an attempt to find the host PC that they are intended for, and the process repeats. So as I click the next button to show these next frames in time, the ARP messages are just multiplying, trying to flood frames and find hosts. Occasionally you can see an ICMP packet get through. That's a ping that's actually getting through, good for them. So some pings will find the correct path just because it's going out every interface. We'll look for some of those in 1 second. One thing we could check on real hardware is the show process, but unfortunately I don't think Packet Tracer supports updating the CPU utilization. In real network, those percentages would not be at 0. They would start to go up. Now let's go back to real time. Right when I do, you can see the green forwarding lights are going haywire. So let's check out. PC1 is absolutely frozen. There was one of those lucky ICMP packets I got through. So what we're seeing here is both the simulated network crashing and the packet tracer on my computer crashing because it just cannot keep up with all the traffic. So when I skip forward 30 seconds of simulation time, packet tracer just can't register the input. It's really struggling. So PC2 and PC3 is same thing, PC0. So let's give this network some relief. We're going back on switch 1, hit the up arrow key to recall the command history, and on this side you can see what happens. Immediately, spanning tree shuts down those interfaces. Breath of fresh air for switch 1, save in the others, take out that no and run spanning tree VLAN 1 to turn spanning tree back on, and skip forward 30 seconds to allow the switches time to reform their spanning tree roles, and let's check out the PCs. Doing so much better. They can all reach each other now. As you can see, that interface on switch 0 is back to the blocking state. That one interface being disabled by spanning tree is all it takes to prevent the broadcast storm. So there you go.